So what we will continue with today is commits. We'll learn how to undo things, both undo changes in the files and also undo commits. And we are also going to learn how to create branches and work with branches later on. In between that, we are going to have an exercise session on commits, and then we'll do exercises on branches tomorrow. But just a very quick recap of what we learned yesterday. We saw that we can navigate through our commit history, or well, investigate our history with git graph, which is just an alias for git log all decorate graph. And we can also see commits that we may have lost by doing checkout or reset, as we'll see later on, by using this additional log called the ref log. So this is going to show by default, so all the commits that are changing the reference for the head. So be it a commit or a checkout or reset, as we'll see later, there are many different commands that change the head. And one important thing to know about reflog is that this is stored on your local computer. So if you are going to share your repository later on, and we'll see that tomorrow, then reflog does not follow along. So make sure that you actually do not change things that impact your coworkers. Okay, so let's go back to the slide. So comparing commits. So we can compare commits by using the git diff command. And as arguments, when we compare, we usually provide two arguments, which are hashes of two commits. In this case is this commit 23 and D3, which are these first and second commits that we have done. And for you, it's going to be a different hash because it's a different author, but it's the same principle. You provide two hashes for the commits that you want to compare. And what you're going to get is something which looks like a patch. So it will say that it's looking into, well, in this case, it's going to actually show the differences made. In this case, it's only one file, the file txt, that showed the differences. And what we have in the second commit, which in this case is the D3 one, is a plus, meaning there is an additional line in this commit compared to the one we are comparing, comparing to the first one. So there is this additional line, more content. So this is what git diff provides. If, for example, we have two commits in which we have many different files that have been changed, then it may be very cluttered to look at git diff with only the hashes as arguments. So what we can provide is after the hashes, there is the symbol double dash, dash dash, or two minuses, and followed by the name of the file that we want to compare in these two different commits. In this case, we want to compare the file txt, so then we provide this particular file name. And in this particular case, we are going to have the same output, and that is because only the file txt has been changed. Only this file is different in these different commits. And the reason why git diff can actually provide this output, so if you remember from the Git under the hood, or what do we call it? The second lecture, Git internals, we are actually storing the blobs of the different snapshots of the files in this Git objects directory, and that is where from Git is pulling out all these differences and enables us to check the snapshots the committee snapshots in different points in time. Okay. So we can also compare all the changes that we have done and have not committed yet. So we compare the changes against the head, and the head is the previous commit, usually. And we do that by using it diff and the argument head. So this is going to show us the differences in my working directory against the head. Now, if I want to see all the differences between my working directory and the index or the staging area, so everything that I have modified but not yet staged, then I do that by using the git diff command. If I want to list everything that I have staged, so meaning all the differences between what I have in the staging area, so ready to commit for the next time, but compare it with the previous commit, so the head, then I do git diff with the option -- cached to a certain commit and investigate the files that way. But yeah, there are different ways of doing the same thing. So how can we navigate the commit tree? So we can do that using the git checkout and the git reset commands. And these commands behave quite differently depending whether the arguments are going to be hashes of commits or if the arguments are filed. So now let's focus what happens is when we use git checkout with hashes. So we have done this a little bit yesterday. So we checked out to a certain commit, and if we were to do this in this situation here, so do a git checkout this, we get into the a detached head situation. So also, another important thing is that when we do git checkout with a hash, then the head reference is going to be moved. But sometimes we have branch references attached to a commit. So in the case we are on the tip of the branch. But when we do git checkout, we are not going to move the reference for that particular branch. So only the head reference is going to be moved. And this is important to remember, as the reset command behaves differently. Also, so git checkout together with a hash, it's going to attempt to keep the local modifications in the file to the files in our working directory. Sometimes that is not possible, and git checkout is going to give a warning or an error. So I suggest that you actually do a git checkout with a clean working directory and a clean index as well. So again, I mean, if we are in this situation, so let's say we have 3 commits. A is the oldest one, 2 the latest, C let's labeled commit C. The master branch points to the latest commit on this branch. So, or let's say the master reference points to the tip of this branch, as well as the head. Now, if we are to do a checkout to a commit, for example, B, then I'm going to move the head reference. So head is no longer going to point to C, but it's going to point to this commit B. But the master branch is still going to be pointing to this commit C. So that's what I just said. So we move simply the head from this commit to this other commit, which we label B. And I can show it example here so that it's a bit easier to understand. So I do just a git one line. I have a head pointing to the tip of the master branch, and I do now git checkout to, let's say, this commit further back in time. And I'm going to get in a git, in a detached head state. Okay, one can actually disable this warning. I do not recommend it for beginners because I think it's important to realize when we are in a detached head situation. But later on, if you know what you're doing and you find this message annoying, then you can configure Git to disable the warning. Okay.
Does it mean that every branch has its own head? Sorry, I got a bit confused.
So by default, the head points to the tip of the branch, unless we are going to do git checkout and git reset, which will take us to commits, to older commits. Now, every branch has a tip of the branch, and it has a reference in this file git refs. So here I have all the heads of different branches. Let's see. Okay. I have a tip of the master branch, which I can refer to as master. I have a tip of the new branch, which I can refer to with new branch, and I also have a reference which is called second branch, and that points to the tip of the second branch. I can actually see what the hash is for that particular branch, actually for any of them. So let's do a cut of all of them. So okay, this was not very useful because it doesn't show me what file is what. So the master branch, for example, has this particular hash. So you, let's show git graph again. I will get back to your question, Johan. So the master branch is still, so the tip of the master branch is still pointing to this hash, even if I have moved the head. Actually, now the head is pointing to the tip of another branch. So we have so the way you should understand branches is like a pointer to the very last commit on that particular line, of code. So master will point to the latest commit on this branch, and that is F1. And then it actually, if I do a git log for master, for example, it's going to show the tip of that branch. So this commit F12 and all the parents commits of that, or well, the ancestors of that particular commit. So F17, the parent commit, which was this one, and then further back in time, the respective parents of all those commits. So this way we get a whole line of commits that the branch consists of. But when we refer to it with the commands, by what we actually mean by a branch is the tip of that branch. So if I do a git log of the reference master, then I get I get the information that is related to that tip. Well, in this case, okay, this was a bad example because it shows all the parents as well. But for example, if I were to do a git checkout to master, then I actually get to the tip of the master branch, and we can do that. So git checkout master. Then I switch to the branch master. So now I can see that I am, so let's see, git graph again. I am on the head is now pointing to the tip of the master branch. This commit F17. If I did, yes, I can show the ref log. So if I, so let's see, I had a checkout, I think to this one. Yes, which was an older commit. And and these are the two commits which I would have lost if I did not create a new branch. Sorry, this one. This is the commit I would have lost. Here is just a checkout to that. So that's because I renamed the branch. But yeah, this is the commit. And now it does show new branch, but that's because Git already knows that there is a reference to this branch. If I were to do a Git ref log before I created this branch reference, then well, this reference would obviously not exist, and I could only see the hashes of those commits. From the Git log anymore. So git reset is another useful command that allows to undo changes in our commit tree, and there are different ways of using git reset. We can have different options. The most common ones are soft, mixed, and hard, and I'll explain what that is. And also it is used, or it can be used with a hash reference. And when we do use that with the git ref command with a hash reference, what happens is that the head is going to be moved from that reference to the head is going to be moved from the current head to the new reference, which I have specified with git reset. So irrespective of the soft, mixed, or hard option with git reset, the head is always moved to the new reference. Now, of course, if I specify git reset some option head, well, the head still stays at head. We are not actually changing that reference, but if this reference is something which is not the current head, then it is going to be, the head reference is going to be changed. Now, if I have 2 seconds and I'll take your question. So if I have changes in the working directory, and also maybe some changes which I have possibly staged, then I can use the mixed option, for example, and that is going to unstage all the modifications that I have done to the index. So it's going to get it to a state of the head. So I will not have any unstaged files after I do a git reset followed by a reference. And this option is the default one. So by default, git reset is going to unstage all the modifications in my all the stage modifications in my repository. Now, if I use the hard option, which is the most dangerous one in a sense, I'm also going to eliminate all the modifications that I have in my working directory. So not only it's going to clear the index, I will also lose all changes I have in my working directory. With the addition of changing the head if the reference is different than head. So, and when I want to actually have this option, it's in the case when I discovered that I have done a very big mistake in my working directory and I want to really revert back all the changes. Okay, so then if you remember, git checkout only moved the head reference, but not the tip of the branch. If I use git reset with a reference, then not only am I going to move the head, but I will also move any branch references that I may have. So if, for example, if I do a reset from the tip of the branch, then I am going to change both the head reference and the master reference. So the tip of the branch will point to an older commit. If, for example, first I did a git checkout to an older branch, so I do not move the tip of the branch, and then I do a git reset from there to an older commit, then I am only going to move the head reference, because in this case I did not have a reference the tip of the branch. So the tip of the branch is going to remain unchanged. So again, if I am in this so-called detached head mode, then I only move the head. If I am at the tip of the branch and I do git reset, then the head reference and the branch reference changes. Okay, before we move on, any questions regarding this tree? So you should not use it if you have shared your repository with some collaborators and it's already on some platform like GitHub or something else. Then it's very it's not recommended that you use this command unless it's something really buggy and should not be there. Okay, so let's move on. Just to make it even more confusing, the way Git works is that you can use these commands, git checkout and git reset, with files as arguments. And then the syntax is git checkout and the name of the file. And in that case, what git checkout does is to discard all the changes that you have not staged yet. So it's going to give you a pristine working directory. So it will clean the working directory. If I want to unstage the files, so I've made some modifications, staged them, and I want to unstage them, but keep these modifications in the working directory, then what I do is I use the command git reset, followed by the file name or the files that I want to change. Okay, so this is, for example, one way you can use this command. So let's assume that I have made a change in the file txt and I stage this modification. If I now use git diff with the option cached, I can track the differences between the staged modifications and the previous head. And in this case, it's even more content. So there is an additional line in the file txt, even more content. Now, let's assume that, I actually realized that I do not want this content and I want to unstage these modifications. So remove this modification from the snapshot. Then I do the command git reset followed by the file name, and then there is simply no difference between the index or the staging area and my previous head. So the index is so-called clean. If I do git diff, and what the git diff is going to do is to show me the difference between the modifications in the working directory and the previous commit. Then what I see is that I still have this modified file, even more commit, in my working directory, even if I unstaged it with git reset. Now, if I want to remove that modification from the working directory as well, so I have a clean working directory, let's say I do not actually want this additional content in the file, then I remove the modifications by using git checkout, followed by the name of the file or files that I want to change. And then I will have some a message updated one pass from the index. And when Git outputs path, it usually means that it has changed something in the working directory. And then again, if I do git diff, I see that there are no differences between the working directory and the previous commit, the head. So everything is clean. No changes in the file txt. And if you remember how it was before, I had these 3 lines. So what I had staged was cleaned. What I have modified later on in the working directory got cleaned.
Okay, I get it. Thank you.
So because git reset and git checkout can be very confusing depending whether you use them together with hashes or if you use them with files as arguments, Git has actually introduced another command from version 2.23, and that is restore. And this only works with files as arguments, so it's not going to change the head. So the head will always stay the same, so it will only modify the index or the files. And so instead of discarding all unstaged changes, the way I've done it with git checkout before, I can use the command git restore followed by the name of the file or files I want to unstage. Discard or unstaged. So if I want to modify all modifications in my working directory, so instead of doing git checkout, I can do git restore followed by the file name. If I want to unstage, instead of doing git reset, I can do git restore staged. So again, the advantage is that it does not change the head, but you can use any of them. And actually what I suggest, if you do not remember these different commands, is to always do a git status, and git is going to suggest some commands that you can use depending on what you want to achieve. Okay, so let's go a little bit through tagging. Sometimes it's actually useful to give a tag to a certain commit. For example, if you have some important milestone in your commit tree, you can list the tags using this command git tag. But if you are looking for certain commits that only have a given name in the tag, then you can use this option -l with some regular expression for the tag. So for example, in this case, I'm looking for tags that have beta in the name. In the simplest case, we can create a lightweight tag. And what the lightweight tag means is that we just add another reference to a commit. So instead of having, for example, the branch reference, if we are at the top of that at the top of that branch, we can add another reference which is called, I don't know, version 1.0 or something. Now, if you share your repository with others, then it's more useful to create an annotated tag. And what that means is that the person that, so the author of this tag is also going to be listed together with the tag. And you can also write a comment, just like you can write a comment to a commit message, you can write a comment to tags, so that you explain why you have introduced this additional tag. Again, this is important when you are working with a shared repository, and you just make it more clear to your coworkers why certain things have been introduced. And also, for example, if you are checking others' repositories, you want to know, okay, what is so special about this particular version of the repository. Okay. And how can we refer to different commits? We have worked a lot with head as a reference. This you can refer to commits by either the hash. This is what we've used a lot, or you can refer to it as a master, as the head, or you can refer to it as the name of the branch, or you can actually write this long name, but that's fairly uncommon, but it is possible. So most important wildcards that you can use with hashes are these tildes, and the head followed by one tilde is going to refer to the parent of the head. So the parent, which is just the commit that is just one commit older than the head. So in this case, the head is pointed to F0. Head tilde is going to point to the commit on the same branch that is just one step lower. So this is the free. If you use two tildes, then it's going to go two commits down from head on the same branch again. And then in this case, it's 23. If, yes. So if a commit is a merge commit, so this one actually is a merge between the master and the second branch, then you can refer to the first parent, which is the parent on the branch, the parent commit on the branch then you are on, and this hat2 is the parent, the other parent on the other branch. And this can be very confusing. I still find them confusing sometimes, so I actually find it sometimes easier to just refer to the hashes. So do a git graph and then refer to the hashes so that there is no confusion about which hash you should be using. Okay, so we actually did discuss this already. So git checkout with a file name or git restore with a file name is going to discard all the unchanged changes. So it will clean the working directory. If I just want to unstage file and keep the modifications in the working directory, I can use git reset file name, or I can use git restored with the option staged and file name. So then you see, I mean, git restore actually does different things depending on the options that you are choosing. So, but these commands only work if files are being tracked. So, and that means if the files have been added to the index, so Git knows about them. If, for example, I create a new file and I have never added it to the index, so Git does not know about it, how can I actually clean that? So let's say I don't know, I compiled my code and I got a whole bunch of files in my directory, in my repository, which I do not want to track with Git, and I do want to clean them. Then the way I can do that is by using the command git clean with some options and the path. Always a good idea is to do a dry run before you clean, so that you know actually what is going to be cleaned in the directory. And there are many different options. So if you do have many files to clean, a good idea may be to add the option -I, which will which is so-called interactively. So it's going to ask you for every file, do you actually want to clean this file or not? Okay, so these are just some examples, and I think that we should take a 10 minutes break before we continue with this lecture, so that we also get time to do exercises. So yeah, 10:15. We come back at 10:15.